right, so in our previous section that we talked about Friday, Monday, we talked about taking a region, and rotating it around an axis, and it created a 3D figure. We found its volume.
Right.
Okay.
Don't slide.
All right. When we used the disc and washer method, how did our rectangles look compared to our axis of rotation? Perpendicular. Okay. So when we used the disc washer method, our rectangles were perpendicular to our axis of rotation. Okay. Okay.
Parallel. Wow.
Okay.
That's bad.
What do you think we're going to talk about today?
Carousel.
That's exactly right. Okay. We're going to talk about taking rectangles that are now parallel to our axis of rotation. Okay. So you need to keep in your mind when we have perpendicular rectangles that we're rotating, okay, we're creating those discs and washers. We can visualize it. If you need a funny word to help you remember it, there you go, perpendicular. Okay? You don't have to use it if you don't want to, but if you like word games to help you remember things, there it is. Okay? So, there's my parashell, right? There are some situations where it is more convenient to rotate parallel rectangles around our axis of rotation. Okay, when this happens, it's going to create what we call shells, what you think of as a cylinder. Okay, so there's my animation. Okay, so we're going to have all of these cylinders that are creating our volume. What? Okay, it's exactly like the disc washer method. We're just creating, we're creating the same regions. We're rotating our rectangles differently. Okay, our 3D figures are not going to look any different. The way we find the volume is going to look different. Okay. So, each layer, okay, looks like this. If I cut it and unwrap it, we have a rectangle with a thickness, right?
Yes.
Yes. Okay. Now, if I lay this rectangle out, how long is it?
Its circumference.
Which is?
Pi r.
No.
No.
2 pi r.
2 pi. That was close to diameter.
Okay. What about, what's this measurement?
Height.
That's the height of our cylinder. Okay, and then we have the width, all right, which is like the thickness, which is, yes, the RDX. Okay. How would we find the volume of this rectangle that we just laid out? Length times width times height, right? Okay. Circumference is 2 pi r. Height I have as h. And then I have width, which you have figured out. Our width is going to be that thickness dx or dy. 2 pi r h. Does that sound familiar to you?
Yeah. Sounds like a cylinder.
That's the volume of the cylinder. So, as we go through setting these up, all right, you need to keep in the back of your mind that 2 pi r h. That's how we're getting our information. Okay? So, how is this going to look in an integral? Okay? I'm going to take that and I'm going to put it actually on around our y-axis. Okay? There's a lot going on here. I know. Our radius, we are going to call x, okay? From the y-axis to any given point on my region is going to be x away. So our radius is x, all right? The height of my cylinders is going to be the difference in the functions. Because those rectangles are sitting in our function, okay? How to find this bottom, that is how we're going to get the height of our cylinders, okay? And then here's our thickness, dx. Can you see that animation?
That's very distracting.
It's distracting?
That's all I want to do is watch that.
Watching.
See what it does next.
I already know.
Okay. So you're saying
Well, that's not good.
epileptic.
Kind of cool what it does though. I mean, they're cylindrical shells because it's just like the outside of a cylinder, the shell of a cylinder. The cylinder would have, you know, a top and a bottom, and it's basically the lateral part of the. Well, it's not surface area. Okay. Is everyone okay with this formula? 2 pi r h. If you can remember that, you can set up the shell method. Okay? This is why, okay, I was so picky about you drawing these rectangles. Alright? If you did not draw your rectangles on your quiz yesterday, I made a note of it. Included it for you. You have to draw these in because this is what's going to tell you. First of all, are you integrating with respect to x or y? Second of all, are those rectangles creating shells or are they creating washers? Okay. So the first example that we're going to do is the example that you have been seeing animated throughout this entire PowerPoint. Go ahead and write down the equations. Ready? Okay, write down the equations. Are these animations at least somewhat helpful? They're not completely distracting here. Okay. Everyone have these written down? Okay. I'll go to where I draw better. Okay. So we're rotating around the y-axis. Okay. If I want shells, I want parallel rectangles. So I'm going to twist that around, and we're going to get that animation that we just saw. Okay? Alright, so our thickness is dx, right? We need to figure out our points of intersection. We have the graph
45x.
y equals 1/2 x and y equals x minus 1 the quantity squared. How do I figure out where these two intersect?
Set them equal to each other.
Right? anyone think of something that multiplies to 1 and adds to 2.5?
Sure. Is it 1 and 1? It's intersection.
Well, multiply to 2 to get 1.
1 half. Tricky.
Okay? So, from x is 1/2 to x is 2. Those are our points of intersection. All right? Okay? We're using our x intersection points because we're integrating with respect to x. All right?
With respect to x, even though you're working on the y-axis.
Yes, because our rectangles have that thickness dx. Because they're sitting
Perpendicular to the x-axis.
So whichever
Perpendicular.
whichever axis that little rectangle would sit on, that's what you are integrating with respect to.
So if it was,
I think whichever axis.
so if you're rotating over the x-axis,
Okay? See, these rectangles, all right, they're sitting, the x's are changing as I make it, right? That little thickness would be sitting on the x-axis. Okay. All right, so how do we find the volume of a shell or a cylinder? 2 pi radius times height.
so x,
Now, okay, our radius is how far our rectangles are from our axis.
x.
At any given moment, that rectangle is x away. Okay? And then, how high are each of those rectangles? From top to bottom.
R to be 1/2 x minus x minus 1 squared.
So
Wow.
you're
Plug it into the calculator.
so you do top minus bottom.
Yeah, because that's how long those rectangles are.
Oh.
Right? That's how high they are.
Okay, so it's like yes.
When we are rotating about an axis, yes. Okay? Tuesday, we'll look at if we rotate about a different line, and that will make our radius change.
But it's just the distance.
It's the distance from the axis. Mm-hmm.
So we're not looking at, so this would never be like, if you're rotating around the diagonals
Then our radius will change. And we'll talk about that Tuesday.
okay, so it's not happening with that one.
Not today. No.
So it's just-
Yes.
I'm just making sure that's what
Okay. In terms of pi, does anyone have an answer for me? Any? 45. Huh?
Oh, okay.
Really?
Yep.
Oh, man.
Are you ready? Okay. That's because this x is
All right, we fixed it. Any questions on the setup? Would you like to try another one?
so you're
Got it. She got this. I'll,
Here's our next one. The region bounded by y equals 0, y equals sine of x, from x is 0 to x. And we're revolving around the y-axis. Are you ready? Does anyone have it written down?
Yeah.
Okay. What does y equals the sine of x look like? Where does it start? 0, 0. And it goes
Up,
up.
down, down.
Okay.
But
But we're only going to
We're only
pi,
going to
so
pi.
this is from 0 to pi, right? What is y equals 0? The x-axis. So we are talking about this region right in here. Okay. Some of us are having some issues. There's a problem on the quiz that we'll talk about where you didn't quite get the right region. Okay. Make sure you really pay attention. Whatever they give you when it says bounded by, that should be the outside of your region all around. Okay. Now we're rotating this about the y-axis, right? Okay. And we're using the shell method. So we have parallel to our axis of rotation, and we get this, right? So we have thickness, dx. Our limits of integration are what? 0 to pi. They were really nice, and they kind of gave that to us in the problem. Okay? So I'll put my thickness out here, dx. All right? Remember 2 pi rh. I'm going to put 2 pi out in front. What's our radius? X. What's the height of our rectangles? Sine of x minus 0. Don't have to write it. Now, we do not have the capabilities to integrate this by hand. In Calculus 2, you will learn a trick to do this, but we don't know it. So this has to be done with a calculator.
Score.
You got what? You got pi? Pi?
Yeah. 2 pi squared.
Then pi times 2 pi squared.
We got squared pies.
All right. Now, Ms. Holman, what happens if we rotate something around the x-axis?
Put a question mark by it and just cross it out.
All right, y equals 4x is a y equals x squared. Okay. So we have a parabola. And we have a line. Okay. Let's see what's the best way to draw this here. Like that. Y equals x squared and y equals 4x. Where are they intersecting? 0 and 4. Okay. Now, we want to rotate this around the y-axis, and we're using the shell method. So we need parallel rectangles. So this time, what's our thickness?
dy.
dy. Because here we're on, so with the y-axis there with that thickness. So, let's see if I can draw this without completely messing it up. Okay. So we have our limits of integration are what? 0 to 16. Very good. Okay. Remember, we're integrating with respect to y. And so we have to look at the y value. Okay. These rectangles are going to stretch all the way from 0 up to 16. Okay. What is our radius? Our radius is y, so 2 pi times our radius times the height of the cylinders. That's just talking about the length of our rectangles. How do we find the length?
No, x squared minus 4x.
Oh, all wrong. What do we have to do?
Square root of y.
Okay, x equals the square root of y, because it's the positive side, right?
Gosh, 1/4 y.
And y over 4 equals x.
Does not equal x.
Okay, so what is on the very right?
The square root of y.
Radical y minus our left equation.
1/4 of y.
Y over 4.
Plug it into your calculator.
Remember, you can use the x in your calculator. It'll still integrate the same. It's the setup that's important. Anybody ask something? No?
Yeah.
2,048 pi over 15. Yeah, you will never get a negative value for a volume, right? Or area between two curves. We can have negative area when we have something lying under the curve from the curve to the x-axis, but you will never have negative if you're talking about between two curves or a volume. Okay, so I'll have you write your assignment down, and then I want to talk about the quiz. You can do this assignment with your calculator, all right? Because what's important here is the setup. However, I will tell you, we will have a quiz on Thursday that will be over the shell and the disc / washer method, where it will be some non-calculator, some calculator. Okay? So just be prepared for that.
Will that be over the